today we are going to be covering nonlinear design, which is very much a companion piece for some of sort of webinars that we've done maybe over the past couple of years. I'm just going to quickly reference one. I'm going to race through this PowerPoint. There's quite a lot to cover. The companion piece webinar, I'd recommend if you haven't watched this webinar, it's Model Builder 101, and it's very much covering everything about modeling with Model Builder, all the details on all the tools, how they work, how you operate Model Builder. Have a look at that webinar. Very, very good resource. As I said, good companion piece to what I'm doing today, because today we're talking about non-linear design. And non-linear design, for those of you that are sort of new to design approach with software, particularly engineering software, is, as I've put there, when a typical cross-section based design will not generate the intended result. I've done a lot of web training over the past, probably more so over the past couple of years, where customers are bringing this type of project to the table. This could be a driveway, by the way. I know it's you'll see very shortly, it's very much sort of commercial industrial style project, but when I say driveway, I don't just necessarily mean a driveway into and over a boundary from a curb. We're talking about the whole geometry, all of the geometry, and a lot of the geometry you can see there isn't necessarily suited to cross-section design with road strings and then variations, which you tend to see people trying to do as much as they can, and really it becomes a lot more hard work than it needs to be. My colleague Todd will be doing a car park webinar next week. I think you're going to be doing a two-parter, I think, Todd. So
yes, I am.
Lovely. So some of what you see today will transfer into his particular webinar, but this project is the one we're going to be focusing on. The non-linear design approach really involves a sequence of different sort of components of the software, namely string design, where today we're going to be focusing mostly on grading strings. For those of you that haven't used them or refuse to use them either way, I'm hoping to bring you over the line on those today. Looking at tools, which I guess we call these design aids, to help us reference different strings together, and then modeling. We're going to be using Model Builder. So the things I've highlighted with bold there are kind of the key areas that we're going to be focusing on. The grading string is the thing that I'm going to be focusing on with regards to the string type today, because I see this sort of firstly underused, and then secondly, I then sort of see people that sort of don't want to go near it. Now, what I'm hoping to do today is to kind of allay any fears or issues with grading strings. One of the great things about Toolspace is that we introduced Toolspace, meaning you can see all your grading strings now in one environment, and this environment, the Toolspace environment, means that you can access and get contextual tools for your grading strings and see them. Prior to Toolspace, and if you haven't upgraded to V24 and are not using Toolspace, just finding grading strings, if you've got 30, 40 in a project, can be very difficult. In fact, I tended to go to delete grading to see the list of grading strings in my project. They are created from polylines. Those polylines are the horizontal control. Have a look at our Getting Started series on our YouTube channel, which really just unpacks grading strings at a very, very basic level, but we are going to be using them predominantly in this project. They do support extra sampled sections. I think for a lot of people maybe going, do they? Yes, they do. And the reason for that is because they support, I'll show this actually when we get to one of the islands on this particular project, but it's quite good to know that if you have grading strings with curves greater than 1 meter, you don't need to add in extra sections. But if you have them less, you can introduce extra sections, which is quite good. Meant to show here, that was the meant to press on my keyboard there to progress this slide through. So it's just an example of where extra sections can be applied on grading strings, and we'll talk about the issues regarding sampling on grading strings when we look at that particular one. We're looking at boundary code trimming as well. So if you haven't used V25 includes in the Surface Manager Boundaries tab, boundary code trimming. What that means is that if a grading string has got sort of spurious triangles that typically are your dumb codes that are sort of linking between different parts of a grading string, particularly if it's closed, you can actually use boundary code trimming in Surface Manager just to get rid of any of those miscellaneous triangles. Lastly, we've also got the Grading String Manager. You have to be a version 25 platform user. So you have to be AutoCAD Civil 3D 2025 or BricsCAD 2025, or BricsCAD 25 as it's called, to get access to this tool. So the project we're looking at today is a job that I've done web training on actually in the last 6 months. We're only focusing on 3 areas: the driveway entrance, probably the nastiest part of this, I'd say, for people tackling it fresh, the loading dock area, and the proposed parking. So you can see here, we're going to be putting in a curb replacement. I've actually done this already to save time, because everything that we're doing with that curb replacement is covered in other media and material. We're looking to really tie in what is actually a road string, which is looped onto itself into the boundary here. And on the face of it, that can look relatively simple, but it actually gets quite complex, because what you're trying to do is basically link strings together that are not parallel, okay, and then model them and maintain a connection between them. So we're going to look at the methodology behind that. We're then looking at how we can then build independent strings that move away from the road design. We're obviously looking at ensuring that we tie up to the level of the loading dock there, specific requirement. And then lastly, we'll be focusing on grading the curb, which is just around this side here, looking at obviously getting rid of the road and introducing a median island. So there's kind of 3 different sections. We're then looking to then combine and build together. Really, the outcome of this is to build a model. Okay, so my intended outcome is to build a model. We could look at subgrade models, which actually this does almost completely off the bat from scratch. If you run it straight for the first time, it does a really good job. But today we're just looking at focusing on how to build a model and the tools associated with getting to this point in the design. So I've turned the the Q&A panel off, because in the last one I did on the driveway checker, it was going wild, which was a huge distraction. So in this particular instance, I have decided to turn it off and leave it all down to Todd. So thank you, Todd. The first part we're going to look at is really getting this road, and this is what the only road string on the job, which if we just highlight here, by the way, I'm in Civil 3D. Okay, so really, other than the fact that this is a Civil 3D alignment, and that is a Civil 3D surface for the NS, everything else is going to be fairly generic from a platform perspective. Okay, and I'm going to, for the most part, use tool space as well, apart from a couple of commands, which unfortunately I will have to use the ribbon for, but we'll have a look at that later. So this particular, in fact, what we might do is just throw up Model Viewer first. I've already created a grading string for this curb. Now, the reason why I've created a grading string is because, quite frankly, why not? Why not, first of all? But this could have been a profile string that I've created for this curb down here. In fact, if we open up a cross-section window, you can see what we've got. This is a straightforward curb with a saw cut. There is a dummy section of road on the right side here, which I've added to this template, and this is only because Todd and I are going to talk about the driveway checking on this. This is purely so we've got something for a vehicle to track over afterwards. It doesn't have to be actually have to be there. We've got a curb, and then we have a section behind which ties up to the boundary. The way that this has been put together, and again, it's just a show and tell section, really. We haven't got time to kind of do it all from scratch, because it's dead simple. We have applied a layback, and if you look very closely down here, you can see that we've put this layback in using the custom variation. We spoke about this in the driveway checking webinar. We also spoke about this in the V25 webinar, and there is a playlist on our YouTube channel dedicated to putting this layback together. So we have repeated this kind of multiple times, so I'm not going to go into the depths of how this particular variation runs, because we've got umpteen resources sort of where we've covered it. We've then taken the boundary code, matched it onto a polyline in this instance, which is just here, okay, which has projected that 2% for me. And then lastly, we've got a couple of variations, which one is for the saw cut, matching that onto the existing surface. And then there's sort of this dummy code, which to be fair is called REB, but I've just basically draped that onto the natural surface. And I said that's just so we've got some surface to have a bit of a play with. Now, as far as this grading string goes, we have a look at it. It's called Kerb Recon. So I'm going to use tool space. So again, I have pre-created these is to save time. You don't want to see me sitting here creating grading strings. We'll be here all day. So the grading string, I've simply used a polyline, popped on a template called entry curb, which you saw the remnants of a minute ago, and then the target surface is the natural surface. I've added a spacing, which is your sampling, every half a meter. Now, crucially, when it comes to putting the layback in, you need to introduce a section at exactly the start of where that layback variation begins. So I can get to this a number of ways. I'm tempted to go ribbon, also tempted to go VGE. Let's go VGE. You can see the center line is matched onto the existing surface. That is the lip or edge of the curb. If I then open up the design data form, sorry, not design data form, model, I'm loath to go through multiple tabs here to do it, but go sampling. That sample is added to a grading string. So I've basically used that start chainage position. If you go back in the recording, you'll see this for the start of that layback. So that's essentially how the curb and this whole area has been applied. So it's quite straightforward at the moment, okay? Curb reconstruction, forcing in a layback, 2% to the boundary here. Now I want to look at how I can begin to tie things in. Importantly, what I have done here is told the grading string to create a surface by unchecking that box. The reason for this is because I need some kind of surface for my road design that is coming up to the boundary to connect into. So if we very quickly just close down the grading string form and head over to our Kerb Recon in the surface and go triangles, you can see the boundary. So this is basically what the relationship is with it in Model Viewer. All right. Now, the thing about this is that if I'm going to be tying in any design whatsoever, okay, and that design happens to be this road here, and that terminates exactly on the boundary, look at the problems that can happen with trying to tie onto this grading string surface. This is fine. Notice how the edge of my design here just sort of overlaps, just a small fraction onto that grading string surface. However, because this is not perpendicular, look at what happens on the other side. So if I want to drape any of these road codes, and we'll go into how that's going to happen shortly, onto this surface, I have no surface at this particular point for it to drape onto, including the EB, which you can see falls short of that particular grading string surface. Again, this is another reason why I've used the grading string here, because I get a surface automatically from my string design here. So, little trick for you. And by the way, if you're seeing lots of thicker red lines, they are the grading string polylines. I've literally just put some width on them to highlight them in the drawing so you can see where they are, okay? So if you decide at any point that you want to tie into a surface, but that surface stops short, then you can adopt something called surface extend. Now, what I'm going to do is essentially create a small piece of dummy surface connected to this grading string and then join it with my grading string surface. So I've got something to tie onto in this little zone here, because at the moment I've got nothing. This could be applied to the back of the layback code. So if you didn't have this boundary here and you're wanting to tie in a string onto the back of the layback, but you weren't guaranteed to grab onto that surface, you could apply the surface extend this way. So we're going to just pop to models, right click and go surface extend models. We're going to go add model, and we'll call this crossing boundary ext for extension. Call it whatever you want. At the end of the day, it's going to create a surface with that name prefixed with SE. The string that we're connecting this onto, and this is the bit which I think possibly causes confusion, is Kerb Recon. I want to grab all the way along this edge on the left-hand side onto the boundary code and extend that code, which is the LBDY code, and extend it by half a meter. It can be a very small amount, to be fair. You saw that distance there, it's very small, half a meter, and extend the code. That basically says, look, whatever that code slope is, it's currently 2%, extend it. If you wanted it to be flat, so you had exactly the same level, you could put value, and that value there will be used. If I leave it as code, it'll extend 2%. If I click build model, you won't see it in the drawing particularly well, but there are some contours. So if I now click on one of those contours, using one of, in fact, let's not confuse it. Let's go to tool space, refresh tool space. There is my little extended surface. Let's turn on the triangles. So that is basically a dummy surface, which is it's live, which if I change this design and change the boundary code, this surface will adopt those levels. Now, let's close this down. What I'm intending to do here is say, look, if my edge of bitumen or my centerline and my road design coming in here get to this boundary, I want to make sure that they have something to match onto, meaning I get this tie-in. So what I need to do is join this surface and this surface together. Not always needed, but I am going to do it so that if either of these two surfaces change, I've got one surface using them. This is a pasted surface. So I'm going to jump into CSD surfaces. I'm going at a fair pace, by the way. So if you are finding it's going too quick, we are doing the recording. Obviously, for those of you that will want to refer back to this, I'm going to call this boundary extension, and then combine this grading string surface, which is Kerb Recon. Don't have to hold anything here; it just automatically keeps selecting, and this surface extend surface, and just join them together. Click Build Update, and then close, save and close. So let's just very quickly head to Toggle Display, and pretty much just turn everything off. I'm just going to turn on the mesh for this pasted surface so you can see what's going on. There you go. Now I've got a surface which I can tie my Road 1 design into. Okay, I've also got another surface I can just connect in other strings onto and drape onto. Let's just close Model Viewer for a second. Now, what we're going to do with Road 1 is ensure that at least as a minimum, the center line ties up to the boundary. You may be thinking, well, that's pretty straightforward, but I'm going to just use it using Auto Profile, or manage it with Auto Profile. So I'm going to head to my road string here, head to the vertical grading. And at the moment, there is a generic design on here. This is actually the original design from the training that we did. But the moment, this point here and this point here are matching up to the natural surface, so they're completely incorrect. Now, the good thing about this surface is that if I make design changes to the pasted surface in any way, to the grading string, this surface updates. So ideally, what I want is for the center line of Road 1 at the start and the end to marry up to this surface automatically. So this is where we can use Auto Profile because it is the center line. We'll go Reference Surface and say from 0 to, I'm literally just going past 0 by about 100 mil. So anything just really picking up 0, match onto the pasted surface. Click OK. Calculate profile. Let's watch this one move. Infinitesimal little move there, but it did actually move. Let's click Close. We've got another one at the other end. The reason why I'm closing it is because, I'll be honest with you, I can't remember the end chainage. We're going to go Auto Profile, Reference Surface. And if you only want to capture that section, i.e. you don't want it to add an IP on here, just put a number just very fractionally smaller than the last chainage. So I'm going to say 714.1 to the end, match onto my pasted surface. Click OK, calculate profile. There we go, got that small change. So my center line, and by the way, if you were designing this with two separate strings, which I've seen obviously a lot of people would do, you've got a car park string or some kind of driveway string on the left side, which is a grading string, which is totally independent, and one on the right side, which again, totally independent. You've basically done the edge of your driveway, just using that technique. Okay, so this is the thing about this webinar, is trying to show you some techniques to adopt that could be applied in other ways. And certainly that little surface extend, when I've shown people that and just realizing, oh, okay, so that gives me a little bit of surface to play with. Don't have to make sure I'm exactly on the boundary, is a great way or a great tool to apply. Now, the slightly more problematic piece with this, and don't worry, we're going to be getting rid of the road in the middle here. It's not going to stay there. We're going to be using Model Builder to cut it all out. The slightly problematic with this is the fact that the edge of bitumen has a 2% fall. If I just quickly show you the template that we're applying, just using tool space here. This is the template which is being applied on road 1 as we speak. So at the moment, my center line is in the right spot. Look what's currently happening to my edge of bitumen, minus 2%. So obviously, at the moment, if I modeled this, I'll be sitting minus 2% from the center line, whereas in actual fact, that boundary could be going the other way. So how am I going to get that edge of bitumen tied into the boundary surface that I've got here, but transition from minus 2%? I don't want to just simply take that code, the edge of bitumen code at chainage 0 and just say match the surface, because it's just going to find the next section and just be straight back to where it was before. So the edge of bitumen needs a transition. I looked at this job multiple times to work out really what would be the best approach. And really, from what I can see, the best approach is to actually design those edge of bitumens with a separate string. Okay. Now, if you're doing this with profile strings, this will work. I'm using a grading string for both edges for the entry and the exit. But let me show you what I've done. I've essentially built, and there's the polyline there to represent it. Just there, look. I've drawn a polyline to represent a grading string. And that grading string is going to do nothing more than allow me to design the left edge of bitumen. And the way that we do that is by heading down to my grading string here, which is just said just a polyline, open up, go edit grading. Crucially, when I've created this, I don't need a surface. A lot of the time, people leave that box unchecked and it's like, I've got a surface, another surface, another surface. Most of the time when you're working with grading strings and you're going to be modeling them and creating one model from them, that model is going to be the surface at the end. Okay, so you don't always need surfaces with grading strings. And the great thing is this form remembers your last preset. So there's no template. It's just a basic grading string sampling every half meter. Let's have a look at the vertical design. Completely nothing. Okay, so what I have done here, what this is going to do is it's going to be my left edge of bitumen design, transitioning from that the back of that driveway crossing into a nice -2%. And depending on how we go for time, I might do both sides. I think I'll try and do that. So all I've done here is you'll notice I've extended this grading string well past or well into the start and the end of the design, okay, deliberately. Because at the end of the day, my edge of bitumen, wherever it exists, will use this string. So even though this grading string is sitting over here somewhere, okay, and actually starting a meter before the actual real EB starts, doesn't matter, okay? All it's going to be doing is looking at this for its vertical design. So what I'm going to do is tell this grading string that it needs to match at the start here onto my pasted surface. So I'm going to go auto profile, and I think I've already pre-created them. I had intended to delete them prior to this, but anyway, what we might do is just, we'll cheat, we'll delete all. By the way, if you do use auto profile, might as well show you this. When you delete something from in here, you need to click calculate profile. If you close the form after deleting and don't click it, it will just come back again. So auto profile. And the first thing we're going to do is, look, I know that I've basically offset this 1 meter from the start. So I'm going to say from reference surface from 0 to 1, match onto the pasted surface. Notice how this surface is getting used and used and used. Click OK, calculate profile, and look, exactly the right spot. Okay, now, then at some point, I need to transition into -2% from the center line of the road. The way that we do that is to apply something called a design constraint. Now, you could use a surface extend. So what I could do is pop a surface extend from the center line and say, right, -2% from my center line for 5 meters, and then drape onto it. However, there's a couple of other ways that you can do it, and it's really just to open up the toolbox to show you how you can do it. So what I'm going to do is go to design constraints and go project design code. And what I want to do is see in this view where -2% from the center line would be. So I'm going to click on plus to create the constraint and put in -2% from road 1 CL. It's a label, so I'm being fairly descriptive. Click OK. It will automatically fill this in for you at the top, okay? So don't be too concerned. What I want to do, at the moment, it's actually showing me where the center line of road 1 is in relationship to this string, okay? I don't want to see the center line. What I want to see is -2% from the center line. So I'm going to say in here, -2. Now, if you want to, you can then uncheck upper, because basically it's going to leave it at 0, which is that line you can see there at the moment. I don't need to see it. So I'm going to uncheck upper, click apply. Okay, that is -2% from the center line. So if my vertical design matches onto this constraint here for a set distance. Really, it's up to me to decide how long that is, and then transitions to that IP there. I know that when my edge of bitumen is told to use this profile from this grading string, it will be exactly matching at the boundary and transitioning back to -2%. This is something we tend to sort of avoid. I think in training, you tend to sort of leave this to right till the end because it becomes slightly more complex, but this is really a great way of being able to manage different parts of your string, not just the center line, okay? So to match onto this constraint, there's two ways you can do it. We can go to the Home tab. You can either pick the constraint. You may not know this, but you can actually snap onto a constraint. You can pick here, and these snap tools snap to whatever reference is in this form. So normally, if you've used this, you've probably gone, well, it matches, always matches to the NS. That's because the NS is listed in here. My constraint is there. Watch what happens when I now use the picker tool. I'm now snapping to that constraint. To save a bit of time here, what I'm going to do is go auto profile. You can also, instead of matching to a surface, match to a constraint. So I'm going to say from chainage, I don't know how quickly I want this transition to happen. So from chainage 8 all the way to the end, match onto the constraint. You'll notice that I've got two in there. L for lower, U for upper. We don't have anything in upper, L for lower. Click OK. Calculate profile, and then close. So that is what I want my left edge of bitumen to follow. I don't want it to be just consistently -2% up to the boundary. I want it to follow this. Just a word of caution about a constraint. You always need the constraint gets projected from your road 1 in this instance. What I have done with road 1, just so we're clear, is add extra sampling on row 1 through this area to ensure that I get extra points being projected across with a constraint. Okay, so I've done that by going row 1, insert sections, and from 0 to 20 meters, 1 meter. What I'm essentially saying there is every meter I'm going to want to project a constraint from the source. Okay, so that's why I've got that. I've also done it for the end. So from 700 to the end, extra sampling of 1 meter. That's where the constraint source is. So I want that to be projected every 1 meter. If I left the sampling on the road at every 10 meters, okay, I probably only would have seen that constraint. I'd probably only match on it maybe once or twice. Okay, whereas this way, I've got lots and lots of sample positions to match onto, which is helpful. We're going to do the same with the other side, and then we're going to anchor the edge of bitumen onto this design. So we're going to head to the, we'll close this one down. We're going to head to the exit, go vertical grading. I've probably done the same thing in here. Let's be fair. Yes, I have. There we go. Let's go delete all. You didn't see that. We'll get rid of that in the edit. We'll click on close. Now, the only thing I've had to do here is because I have no sample at this particular location, I've actually introduced one on this particular grading string. What you'll notice is that as we take this grading string up to the boundary, I've got no sample line here, okay? Which means that if I wanted to perform a constraint or some kind of match, I need a sample position in that spot. So if I go to the Model tab, add sampling, I've added a sample onto the boundary. Look, and if you go a bit gung-ho with sampling, this is where it can become a little bit confusing, thinking, hang on, am I adding sampling to road 1 or am I adding sampling to the grading string? Which is which? So when it comes to simply matching onto a surface, which is what this grading string is going to do first of all, wherever I have a sample position on that grading string, I will get a point where I can match onto the surface. Now, what I should have done here was probably check that box to show it in the vertical grading editor. When it comes to a constraint, the sampling is from the source, i.e. row 1. So that's hopefully that makes some sense with regards to the difference. Let's click OK. There's that sample. So that's the boundary. So this means if there's a sample there and I go match the surface, I'll have a match at exactly that spot. So let's do this. We'll go Home, Auto Profile, Reference Surface, which you sort of saw a minute ago, and we'll go from 12.292 to the end, match onto the pasted surface, please. Click OK, calculate profile. That is the boundary, okay? The fact that I've got this spurious sort of vertical design past the boundary doesn't matter because if the edge of bitumen for my road 1 only exists and stops right here, it'll just use whatever it can see. There's nothing here for it to grab onto. It won't. We'll run the constraint again, calculate profile and close. Design constraint is pretty much going to be the same thing. We'll go -2% from centerline, just for speed. Click OK. Automatically, it will fill it in. Row 1, I don't know, I just picked the wrong one there, didn't I? I did project design alignment. Let's delete that, and we'll go project design code. This is my favorite. This is the one I always use in training. This is the kind of the go-to design constraint, -2%, row 1, centerline. By the way, I've put a search offset in here of 5. I'll talk about this in 1 second. So I'm going to go -2%. Please show me where the left edge of bitumen is. Apply. Don't want to actually see the original. Apply. So that's where my left edge of bitumen is at -2%. So I know that that's my tie-in. This is when I start to get back to my original. So I'm going to go home, auto profile. You can also use the manual snap. There's no right or wrong way of doing this. This is just a quick way of doing it. You can also attach this in with a thread. So I'm going to say from 0 to 6, match onto the lower constraint. Click OK. Calculate profile. Done. Remember, these samples are coming from row 1. The more I've got on row 1, the more of a constraint I'll get. Now, just a word of caution about this, because the constraint itself has what we call a search offset. A search offset says how far it should look for, say, for example, -2% from the center line. Because we are 2% from the center line over here, the center line exists in 2 spots, doesn't it? Okay, so I've deliberately put a small search offset to make sure it picks up that part of the center line and doesn't go 2% from that part of the center line. All right, just be aware of that search offset being available to you. Now, as far as this goes, if you guys have used threads, I'd recommend you look at threads in our YouTube channel, because threads allows you, even if you just use them for this one thing, to automatically update an auto profile. So rather than coming in here and clicking this button, which refreshes your auto profile entries, rather than going auto profile calculate, you can have a thread which will automatically update that particular auto profile entry for you. And have a look in our YouTube channel for threads. Absolute gold for this type of thing. In fact, just so you know, while I was building this and putting this together, if you want to quickly get CAD output or line work polylines in the drawing, head to tool space, and you can do this right now. Output CAD entities and just double click. That will generate for you polylines without you even having to go to CAD output. If you then head down and want to get rid of it again, refresh labels and clean up line work, double click. Gone. All right, so if you, the thing about this job is that I needed to snap onto things, and obviously the civil site design fast draw line work is not easy to snap onto at certain points for the geometry. So a lot of the time I was just quickly CAD output, draw, then running a refresh to clean up. All right, so we know the center line's in the right spot. This edge of bitumen and this edge of bitumen now need to anchor onto those grading strings that I've created. So to do this, we're going to head to road 1, design data form. Conveniently, kind of got some of this pre-created because, again, it's not how do you apply design variation. It's, hey, look, there's a variation in here to anchor a code onto another string to use its elevation. So I'm going to say from the LEB here, from 0 to, you can see where it terminates, 20, not 200, 20. Select method. The method is going to be, you could use change offset and level, but if you notice, I'm not changing the position of the LEB with this polyline, am I? This grading string, it's staying where it is. So I'm going to say hold the offset, just keep the offset where it is, but change the level using the string called entry left side. We'll click on add update. I really should have had something here to show you guys how that would have looked. If we'd have had a cross section of row 1 open, that would have made more sense, wouldn't it? So let's just bring this in here. So if we head through from, there you go. You can already see, look, chain is 0. I'm at -3. And as I go through to 3, 4, 5, 6, 7, 8, 9, 10, 13, I'm now where I had to set that transition up to -2, -2, -2. So my left edge of bitumen is now tying up to this point here. I'm going to do the same at the other end. So I can already see the end chainage there. So for the LEB, 714. And again, if this was just an independent string, you wouldn't even be doing this because this would just be a single string and you'd be doing that transition through the VGE. All the way to the end, hold offset, change level. I could do change offset and level. It's not going to make any difference. Left side, add update, open up a cross-section window for the end of the design. By the way, I'm scrolling in this area. If you scroll your mouse, there you go. Now, if I get to the end of the design, I'm scrolling backwards, which is why I've got this. Let's just double check here. Why did I do that? Why did I pick 714? What I wanted to do is to use that string from chainage 700. So let's just go 700, shall we? From 700 to the end, use that grading string to control the left edge of bitumen. There we go. It's a bit better. Now, the right side is all kind of is going to get trimmed out very shortly with model builder. All right, but the left side is really what's important to me. I'm getting that -2% and transitioning into a boundary that is not even perpendicular to the string that I'm working with. So how do we then begin to look at joining all this together? Well, I might start doing it now, even though, or am I going to do it now? Yeah, I think I will. I'm going to just tidy up the road and then we'll look at how we're going to create these 3 remaining strings, which are quite straightforward. Let's just tidy the environment up a little bit by going to CSD Surfaces, Toggle Display, and turn off the contours. Sorry, the mesh even for this design. There's no point looking at this in model view at the moment because, well, actually saying that, let's go and have a quick look. The reason why is because you can't really get a sense of what's going on. We'll go Toggle Display. There is a road string here. So what I'll do is I'll show the total model, which is just the road, show the Kerb Recon, and just show you how those two tie up. So look, that center line is tying up to the boundary. The edge of bitumen is also tying up to the boundary. There are going to be some, I mean, look, you've got all these extra codes in here. We can talk about that probably at the end as to how you might look to tie those in as well. And for some reason, maybe I haven't rebuilt my model yet. There we go. I hadn't refreshed auto model when I went to the design data form. There's the center line and there's the left edge now marrying up exactly to that pasted surface. So you can see, got a bit of a mess now with regards to the road. All we're going to do, and this is what we did in the training, is now look at how we can slice out the right side of the road pretty much as far as this curb down here, and then also remove the right side of the road from this curb all the way to the end, whilst maintaining -2%, or sorry, +2%. The way that we would do this is, if we just close this down, is to use Model Builder. This is where we could adopt this at the end. We could do it now. I think it's kind of good. I'd probably be doing this now, starting to cut out the bits of road that I don't need. Have a look at the Model Builder webinar that we did, because it's almost verbatim a copy of what I'm just about to do. So we're going to create a Model Builder model. Again, not going into huge depth on this. I'm running a bit of a weird screen resolution, so if you see certain buttons looking not quite right, it's my computer. We're going to call this model design. Linked to auto model, because any changes I make to the road design, the road strings, network strings, which there aren't any, that'll be applied. Apply some boundary retraction, create model. What I'm going to do is combine, at this moment, all the grading strings that I want to join to build this model. So road 1, edge, I don't know. Now I'm thinking to myself, I probably should have done Model Builder at the end, because you know what these edges are about. But anyway, we'll cover that in a bit when we get to it. We're going to add the the Kerb Recon at the top. And I think maybe add the parking island at the end. Pad, we'll add the building pad, which is, again, just a grading string with an elevation on it. Notice how I'm not adding these, entry and exit. Not adding those in because they are controlling the left edge of road 1. Whenever you are using match to string and using a string to control the elevation of a code, you don't then add that into your model, because you've essentially got the left edge of bitumen and then you've got another string underneath it with a center line. You're trying to model two things at once. that are doing essentially the same thing, so we don't include them. We'll click build. It's already beginning to look okay, but obviously we've got some issues here. So we're going to get rid of the right side of road 1, and the way we're going to do this is to go to Edit, Road 1, click OK. Then all I'm looking to do is to trim out road 1, the entire right side, from chain 0 down to roughly where these two strings overlap. So I'm going to go Edit Trim by Group. It's a holistic way of getting rid of whole big groups of code. So this is the one I'm after. Keeps the center line, but gets rid of the right side. Now, at the moment when I click on that, you can see it removes it entirely. What I want to do is to say from chain 0 to somewhere here. I don't have a sample line there. They are being displayed, but for those of you that know Model Builder, I need a sample at that position. I am going to just use this option here, because Add Region, by the way, got introduced post-webinar. That needs me to pick 2 points. I don't want to pick the first point because it's already stored. I actually only need this point. So I'm going to go Add Single Chainage. I'm going to make sure there's an overlap deliberately. There. 78.23, click OK. 78.23. So my road is being trimmed all the way up to that point. Click OK. Then I need to do the same thing up here. There's a whole question around elevations which we're going to resolve. Edit Trim by Group. And this time we don't know this chainage. Oh, we could probably pick the sample that's there. Maybe we'll just pick the sample. So pick just ahead of it. You can see it says 620. Always pick ahead. It always finds the nearest previous sample line. So at 620 all the way to the end, you can see that's got rid of my road. On the right side, click OK, and then click Build. All right. So as far as getting these edges all tied in, we're going to focus on the loading dock first. We're going to close down Model Viewer, Model Builder even. And we're going to leave the contours, probably just leave them on for the time being. We're going to head to CSD Surfaces, Toggle Display, and turn on the line work, turn off Total Model. So Total Model is my original line work post trimming in Model Builder. Turn that off, click OK. So what I want to do is ensure that this grading string here that I've created does 2 things. Basically transitions from -2% off the road design, off that curb, but then marries up to a spot on the building here, which is 673.85. And the way that we do that, and this is called Edge 1, the way that we do this is through the VGE, Vertical Grading Editor. Completely generic at the moment. There's nothing referencing anything at the moment. Auto profile is completely empty. So what I need to do is I'm going to make sure that this start point marries up to -2% from the center line. What do? I use a surface extend. I could use a design constraint. There is also another option called reference point, which could also help here, but a surface extend is just a flexible area for me to drape onto, and I kind of prefer it for this particular example. So we're going to have to do the same thing. Why don't I just close the VGE? We're going to have to do the same thing down here, because this string is going to be marrying up in a similar fashion, okay, to the positive 2%, sorry, not -2%. So we will go ahead and create a couple of surface extends. First one, going to go chainage 80 meter. Click OK. The string is road 1. There is no edge of bitumen here, don't forget, so I'm not going to be picking that. I want to say between chainage 60 to 100. Don't need to do the whole string, that would be absurd. On the right hand side, from the center line, I'm going to put a value here because the center line doesn't have a slope, a value of 2%, and we'll project out 10 meters. Build. If I just show you what's just happened here, these surface extends are really good. Toggle on triangles. I can now drape this grading string onto that, knowing that I'm 2% from the center line. Okay, we'll do the same thing again. Add model, chainage 620. You can be as literal as you want with your naming of your surface extends. Let's just zoom out, head over here. Row 1. We'll go from 600 to 640. On the right-hand side, same thing again, isn't it? Center line, extend 10 meters out, just so I've got coverage. Crosswalk method is a value of my choosing, which is going to be positive 2%. And the reason why I'm going to change the number is because actually this whole string here needs to have something to drape onto. So I've actually need to extend this much further. So I'm going to say up to chainage. You'll see why when I do this, 690. Build model, close. So it's getting a bit messy with contours and whatnot. I'm going to turn this off. I'm going to just hit refresh in tool space. Not that I needed to, I've just realized, and turn on the triangles. This means that if I have any point where I need to ensure that I'm 2% from the road center line, this surface model I can just drape onto. So how are we going to do this? Let's just first of all go to toggle display, turn off the mesh, and turn off the contours. In fact, we might just leave the meshes on for this just for clarity so you can see exactly what's going on. We'll open up the vertical design for the first edge, which is this one here, vertical grading. Now, I can choose how much of this surface I drape onto. So I might say, look, as far as say chainage, you see the tracker there, roughly say chainage 7, from 0 to 7, match onto that surface extend. I've used this to absolute death in training. It just gets used all the time. It's such a good tool. Click OK, calculate profile. Obviously, I'm way away with that original design there. However, I need to fix that last spot. That level there needs to be sitting at 673.85. Now, to do that, you can either manually edit that or you can actually force it using this fixed level. If I go fixed level, you can actually do this over a range, 673.3.85, and literally just grab the end chainage, but just go a fraction before it. So I'm going to pick 11.4 to the end, click OK, calculate profile. There you go. So you could obviously do this manually. There's no reason why you couldn't. It's just the fact that this saves a lot of time and effort. I've now got a perfect match in of -2. I'm continuing at -2, setting the level here, which is locked. And then I could obviously reduce the amount of automation there. I can do the same with this string over here. I should really be getting model viewer fired up. I'm really sorry, but it's just time trying to open up different things, showing you how things are looking. Let's go to toggle display. Just open up the model builder model.
Hey, Jonathan, speaking of time, it's 10 to 2.
Thank you very much. Okay. There is my grading string sitting at 673.85. There is my, if we go toggle display, this is a good one if you don't know about it. Object display, show the line work of your model, really helpful. There we go. So I'm now getting a really nice transition up to the building. Obviously this one, not so much, but I'm going to apply the same process. So I'm going to minimize this, going to open up my grading string called edge 2, which is being drawn, I nearly said clockwise, it's being drawn both ways. So I'm going to go vertical grading and the spacings. Let me just quickly mention the spacings on here. This is crucial for grading strings, okay? The general messaging we've given about grading strings has been, if you have a small curve on your grading string, such as this one here, your sampling has to be small enough that when it gets to that curve, it will draw enough samples around there for you at whatever number you put in. So a lot of people for this grading string would put in like 0.1. Whereas what you can do with a grading string is if that radius, such as this one, and this one, is greater than a meter, not equal to, but greater than a meter, we will actually put, as you can see there, sort of extra chords in. We build in this in for you. In fact, if I just turn on the sampling, go regen, wait for our little, there we go, thing to self-destruct. You can actually see, look, there's actual automatic extra sampling going on for that curve. Whereas on this one down here, there wasn't. So the way that we manage this with a grading string is you can actually put your sampling to quite a reasonably high number. I could have put like 3 or 4, 5, 10 meters. It will still pick up the geometry points for me and still draw the extra chords through the arc. But where you have a radius that is less than, where you have a radius that is equal to or less than a meter, you have to introduce extra sections. So I don't know why I'm going through here. To get to that for a grading string, at the moment, I have requested, hopefully the development team hear this, but I have requested that we can put extra sections in on the tool space. Ribbon, extra sections, click, and look, just in that range there, using pick, start, and extents. I'll do it again. Look, click and click, add in sampling of, you could put 50 mil if you want. Refresh, you don't have to click OK, refresh, see the result. And I can get rid of this one up here, delete. So I wanted to mention that because that does occur on other grading strings on here. That radius there is less than a meter, so is that one. You have to introduce extra sections, but it means for your sampling, for your whole string, you can have a large sampling value. Let's just turn off the sample lines for that, and let's just get back to what I was showing you before, which is to introduce the levels. So, oh, that's right, yeah, because I was going to. So yes, they will appear, by the way. You can't do anything about displaying those unless I had that box checked. I can't remember. So what I'll do is now go to Auto Profile, Fixed Level, and say from 0 to, 673.85, from 0 to 0.1, and then Calculate Profile. That fixes the start of my grading string to where it should be. Now, it's up to you, obviously, where that transition occurs, but I'm going to sort of say, look, if we click on Close here, I get to this particular point, roughly around here, around about chainage, 7-ish, match onto the positive 2%. Okay, and then I want it to stop when it gets to that corner, which if I move my mouse along is going to be this chainage here, and that chainage is 40. Conveniently, it's a round number. So I'm going to Auto Profile, Reference Surface from 7 to 40, match onto my surface extend, click OK, Calculate Profile, and close. Then really the requirement for this was to grade all the way around the frontage of the building, and the building would have a retaining wall using linearly vary to basically step down with the edge of the car park. What I want to do is then tie up the end. Okay, so what we're going to do is come down to Auto Profile, and again you can decide the extent of running in and matching up to this 2%. We'll go Reference Surface from, let's just say, chainage 110 to the end, match onto this time this particular surface extend, click OK, Calculate Profile. So look, from my perspective, okay, just getting users to understand how to tie things in, you could do what you want around this corner. You can begin to grade. I will be running a session in the next couple of months about COGO points, so you can begin to set elevations referencing other parts of your design. Todd's going to be doing car park design at the next webinar, so there'll be more discussion, I expect, on relationship between different parts of the design. Let's just close this down, and we'll just head back to Model Viewer, which I've still got open, which means I have to somehow get my taskbar to display. There we go. So I've got that fixed point. I've then got the -2%, sorry, I keep saying minus, positive 2% to this particular location. It then grades round. You've got the extra sections being added in here. And then we've got that tie-in back to this particular point. So as far as the modeling goes at the moment, pretty happy with how that's looking. One thing I'm going to do just to finish off, look at that, perfect timing, is to just talk about how you can then add this particular string, this island, and drape it onto the design. So what we'll do is just going to turn off, using toggle display here, some of the mesh. Again, I apologize if we've gone very quick here. It's because there's a lot to try and fit in, but hopefully some of these principles you can take away. The reason why I'm not seeing the grading string here is because the line work is drawn on total model for any string, including grading strings. So as soon as you turn the model line work off, what will happen is that you then are not going to see the original string, which is why I'm not seeing it. So I'm going to just go back to CSD Surfaces, toggle display, toggle on the line work for total model, and click OK. Okay, so I'm getting the original line work, but as soon as I add this into a model, I'll then see it. So there's two ways you can do this. You can either create a copy of your model builder model that you've got right here, and then drape your island onto it. What you're not going to do is drape this grading string into your model builder model surface, and then add that grading string into your model builder model because it's going to be referencing itself. So we have to take a copy. The way that you would do that is to go model builder, right click, copy, and copy the model. And then you've got something you can basically add the island to whilst draping onto the original, something that we cover in the model builder webinar. The other way that you can do this is to actually just simply paste this island, this grading string, onto your model builder surface and create a pasted surface. Remember what I was saying about the fact that the outcome for this was a model or a surface. So the way that you can do this with grading strings is, first of all, we'll go parking island, vertical grading, auto profile, reference surface, and all I'm going to do is just match onto my built model. Click OK, calculate profile, and close. Okay, you might have design requirements for this in respect of levels. I appreciate drainage is not something I've spoken about, but the drainage would obviously form a significant component of all of this design. But my focus is how we can actually just get the model to look how we want it to look so the drainage can be designed. Okay, this is a grading string with a surface. If we have a look at the actual grading string here, cool, where is it gone? Parking island, edit grading. I've unchecked that box. I now want to paste that together with my design. And the way that you would do that is create a pasted surface. Just one thing, by the way, with grading strings is that with grading strings, you may find when you create a closed shape and go create surface, you get spurious triangles, only on closed shapes. The way that you can manage that is through Surface Manager. I highlighted this on the first slide. Grading strings, if we go parking island, are subject to filter code by triangle. So you can use this tool. Have a look in our V25 playlist on our YouTube channel to explore it a little bit more, but it's relatively straightforward to get rid of any miscellaneous triangles on that grading string that get created. So I'm simply going to paste this onto the design. Okay, and just one tiny thing I'm going to mention, I expect I'm stealing Todd's thunder here, but if you do want to create a low point in here, in this particular area, or even if it's here for drainage, you can just simply create a point. I just type the command point there, give that an elevation, and in Surface Manager, this goes on to my point about drainage. In your built model, not many people realize, but you can add 3D faces, points on layers, break lines, 3D polylines into a model builder model. So if you've got a third party or whoever else, somebody else has designed and they can give you 3D polylines for your driveway design, wherever it happens to be, you can incorporate them into a model builder model. And I could use that CAD point there with an elevation and use its layer, which you can see it's layer 0, bad layer control, and that would be modeled. There'll be a triangulation to that particular CAD point. Let's now just paste everything together. So I'm going to go CSD surfaces, paste surfaces, add group, and we'll call this final, add surface. We're going to go and add the built model and the parking island together, select. Obviously, I want the built model to be drawn first and then the island to be drawn afterwards on top. So that's why I've done them in that order. Build update, save and close. Let's go and have a quick look at how this looks in Model Viewer. There was an option in that form to introduce codes into your pasted surface so you can do all the rendering. We'll go to Toggle Display. If you wanted to just see the parking island, you just check on the box, click OK. There's the island. If you wanted to see it as one complete surface model, by the way, that's how it's looking at the moment. Don't worry too much about the rendering. If you've got time, I might just quickly mention about how we can deal with these codes here, but the rendering is not too much of a concern. Let's go Toggle Display and show the pasted surface instead, which incorporates everything. So I can now use, if I decided, I could now use Export Surface. Export Model wouldn't take the line work of that particular string, but I could export it as two separate models. Export Surface would now give me the option to then export that out as a final finished design. So hopefully, I'm going to do the driveway check as well. Well, maybe we'll talk about the driveway check very quickly. For those of you that did the driveway check in webinar and have seen it, this is just something that Todd and I wanted to mention. When you run the driveway check, if you want to check a proposed design, This is dead simple. Have a look at the webinar. But if we go to create, click on the grading string. I just want to show you, if you want to ignore the optional layback shape and basically say, just use my design that I've done here, lift this entry blank. I'd forgotten the fact that that says optional. Leave it blank there, and put the back of Kerb code for your driveway check. What will happen is it will simply, if we click on cancel here and we go to design and pick our polyline, get that lovely. The polyline's not there anymore. That's why. So let's just go back in and go to create. Left side driveway extents. I think it's this polyline here. That was the same number. Target surface. That would also be helpful. Let's go built model. Create driveways, and then we'll go design. There you go. So what I'm actually seeing here, if I run the analysis, I'll actually be tracking over my design.
Reduce the vertical exaggeration.
Thank you, Todd. Yes, I thought that might be there we go. Doesn't look quite as bad.
Yeah, it looks more realistic.
It does now. Looks like you could actually drive over it rather than have to use crampons. So
you could even extrapolate that concept if you'd done a model all the way through to, say, the back of a footpath near a property line. You could make that your matching point.
Yep.
And only really leave the bit between that and the actual connection to the property as the variable, and then you could check a proper full-on design. So you could use this tool as more than just the concept design. You could certainly use it as a design check after you've modeled it. There's one question that came in early on, but I thought it'd be good to answer. So thank you very much for waiting so long to hear the answer to this question, but I thought it'd be beneficial for everybody to hear the answer. And I'm happy if you want to take it, Jonathan, or I'm take it. The question was pretty much, why would I use a grading string versus a profile string? What's the differences or the benefits?
Yes, good question.
And it is a very good question. Do you want to, or are you happy for me to
answer?
It
definitely. I'll be interested to hear your answer first before I.
So it comes down. They're similar in nature, but they have different author elements. So a grading string is using a polyline as its author in terms of horizontal position, whereas a profile string uses an alignment. Now that has an implication with change in direction, because a grading string can have an instantaneous change of direction, whereas a profile string, if you are doing some sort of cross-sectional model to it, really needs some sort of curvature at every change of direction to allow for the offsets to work. Whereas the grading string, as Jonathan is very kindly bringing up on the screen, has this idea or this concept of corner angle increments and cleanup, which allows you to clean up the corners. So if you were, say, modeling a retaining wall or an open channel or something like that, you can get a really sharp change of direction, and the software will spray out angles to clean it up for you, or to clean up the inside, depending on which side you're on. A profile string doesn't have that.
No.
Yeah, exactly. A profile string doesn't have that aspect.
No.
So that to me is probably the key bit, is that idea of corner cleanup. The other thing that grading strings are far more flexible on, and Jonathan's shown you this a couple of times today, is closed objects. So if you were modeling some sort of pad, some sort of basin, some sort of island, like he was just showing you at the end, that's where a grading string is really great, because it does the cleanup on the inside for you. It gives you the ability to infill the middle, whereas a profile string doesn't. Neither does a road string. So a profile string and a road string are very much related. They're very much brothers and sisters of the same type of thing, but the road string has the other aspect of the network componentry, so your curb returns and cul-de-sacs and whatnot. But hopefully that answers the question. Another question's just popped in. Can grading strings be given subgrade profiles? They certainly can. Grading string still has the ability to have templates added to them, just like you could on any other type of string. So the moment a template has been added to a grading string and it has subgrade, then it would be able to be included in the subgrade models and in the volume calculations. So that is very much true as well. Question-wise, that's the only stuff that's come in. Is there anything else you want? Oh, there you go. Jonathan's even just brought it up for us.
That's literally just me pressing create subgrade model. That's what I get. Yes, I probably would have incorporated this parking bay into another model builder model. I could also add maybe a very thin piece of subgrade to the edge of the building pad here if I wanted, so that it got some kind of definition. But this is what you're getting out of the box.
Yeah. So I guess that leads to one of the benefits or similarities between the three major string types in CSD, which is the road string, the profile string and the grading string, they all can have templates. Those
Yep.
templates can be as simple as a single code or as complex as a full cross-section of a road. And if those templates have subgrade componentry added to them in terms of layers of materials, then you can build subgrade models out of them as well. Thank you very
Thank you,
much,
Todd.
everybody, for attending.
Thank you very much.
Thanks. See ya.